Hello and welcome back. I know last week we spent a lot of time covering chemistry, and if you notice this week, my first video, I've got organic chemistry up here, and you're probably thinking, oh, when did I sign up for a chemistry class? Really, this is the little bit here at the front is going to be the last bit of hardcore chemistry we're going to discuss. I want to make sure everybody's on the same level before we go into the macromolecules that are associated with biological systems, okay? And when we're talking organic chemistry, we're talking about compounds and molecules that have carbon within them, okay? Specifically, carbon and hydrogen is what's needed to classify something as organic, okay? Inorganic compounds are going to be a little bit different, all right? Or inorganic compounds, you may have a carbon, but you're lacking a hydrogen. Okay, that's going to be what is going to differentiate something that's organic versus inorganic. All right, there are some other things that differentiate organic and inorganic. Okay, inorganic compounds, usually this is where we have our ionic bonds. Okay, whereas organic, these are going to be covalent bonds that are going to hold our elements together, okay? Inorganic compounds very often are going to contain positive and negative, all right? So you're more likely to see ions that are going to be inorganic, okay? And typically with inorganic compounds, this is associated with the non-living components of our environment, okay? Organic compounds, we've got covalent bonding. Typically, organic compounds are going to be much larger than inorganic compounds. We're going to talk about some long chains or polymers this unit. And carbon, or the organic molecules, are going to be associated with living matter, okay? When I talked last week about carbon, all right, and I drew those electron shells, in the outermost electron shell, carbon had 4 free available spots to accept electrons. Okay, carbon is really our scaffold. Oops. Or our building block for what we're going to talk about next. Okay, and if you notice, I kind of drew things a little bit differently than I did last week. This is just a different nomenclature or a different way of presenting how bonds are connected, all right? In this case, because carbon has 4 available electrons in its outermost shell, I drew 4 lines, okay? And that carbon can combine with hydrogen, oxygen, phosphorus, nitrogen, okay? It can also combine with other carbons, all right? And I'll put that over here, okay? In terms of that, that's what makes carbon very versatile. And what we're going to talk about with our next macromolecules, they're all going to be long chains of carbons strung together, okay? So that's why it's important to understand what's going on here, all right? We've got carbon and hydrogen. That's going to make it organic. If it's organic, it's associated with living, okay? If we have just carbon and hydrogen, this is going to be classified as a hydrocarbon, okay? Hydrocarbons are a lot of your flammable materials like propane. Butane is also a hydrocarbon. Typically, if we're talking about living organisms, it's carbon, hydrogen, plus some other elements. And those other elements can be the nitrogen, the oxygen, the phosphorus, okay? So in terms of that, I've got this drawn simply with just one element attached. That isn't the only way that carbon can bond to things, all right? And we'll erase these because what I'm going to talk about next are going to be functional groups. And I mentioned very, very briefly last week. What color can I use? Let's use pink. Functional groups, when I talked about acids and bases, okay? That functional group I talked about was the OH minus, okay? That was our hydroxyl group, okay? So a hydroxyl group is one example of a functional group. And in terms of that, it's going to be one that you're going to very commonly see in chemical structures related to biology. Some other functional groups that I want you to be able to identify . This is an amino group, okay? When we talk about proteins and amino acids, guess which group is going to be found in amino acids? It's going to be an amino group, okay? So this is going to be another group that's important biologically, all right? Also related to proteins, which we'll get to, are going to be is going to be another functional group that's going to be the carboxyl group, okay? So the carboxyl group, this is also going to be important when we talk about amino acids. So these are two functional groups that play a big role in protein structure, okay? So we've got hydroxyl, amino, carboxyl group. The other one we're going to have that can attach to, say, our carbon is going to be a phosphate group. Okay? And I should put another bond off of here because these can connect to something else. And I'll show you that on the carbon here in a minute. Okay? Phosphate group, where this is going to come into play, is when we talk about DNA molecules. Okay? So in terms of that, we've got our main carbon here. Okay? We can just connect this one here. All right? Carbon to a carbon. And we've now attached a carboxyl group, okay? We can also attach, say over here, maybe an amino group, okay? And what I've just done by attaching those two functional groups to this one carbon is this is the beginning structure of our amino acid, okay? So carbon is really versatile. How those bonds form are going to be really important. The thing to remember here is these bonds, whether I drew them in pink or whether I drew them in green, it doesn't matter. each of them is a covalent bond, okay? So with our organic compounds, they're going to be held together by covalent bonds. So these are some of the main functional groups. I think your textbook has a couple others. There might be a methyl group in there, our carbonyl group. These four, hydroxyl, amino, carboxyl, and phosphate, are the ones I want you to really focus on, being able to identify the structure, okay? Meaning if I show you a picture of this here, you're going to be able to tell me, oh yeah, that's the amino group, okay? Because functional groups are going to become very important with the macromolecules that we're going to talk about next, all right? Let me know if you have any questions. Thank you for your attention.